Welcome back, and with this video we are talking about multi-step equations with distribution. So these guys are going to have a distributive situation, and we got to take care of that before we can really access the variable. So how does it look? We are first going to distribute and then isolate our variable. So here we go. Distribute first, then isolate our variable. So we have 5 times 6x minus 6 equals negative 270. And we're just going to distribute first. So I have 30x minus 30 equals negative 270. Now, this guy might give you some large numbers, no big deal. But once you distribute, you're back to a two-step equation. So we have to identify our variable term, which is right here. And then we're going to get rid of that plus 30, or minus 30 by plusing 30 both sides. Remember inverse operations. These guys cancel, and we have a 30x equals negative 240. We do have to understand our integer operations decently well. Remember, this is a negative 270 plus 30, so we have negative 240. And we are just going to divide both sides by 30, both sides. And we have x equals negative 8. Done. And if you're like, that's a big number, Mr. Michelson, how did you do it? Well, you could use a calculator if you need to. But there you go. So pretty much you distribute, and then you're back to a two-step equation. Let me show you guys one more over here. 4 times 2x plus 5 equals 36. And we are going to do our process. Distribute. We have 8x plus 20. Remember, 4 times 2x is 8x. 4 times 5 is 20. And from here, we have our two-step equation. So we're just going to try to get our variable term by itself, which is that 8x. So I need to minus the 20, or get rid of that plus 20. So minus 20 both sides. Remember, inverse of plus is minus. What we do to one side, we have to do to the other. And we have 8x equals negative. Nope, that's a positive 16. Whew. Go for that. Positive 16. Sometimes I've seen when I try to go fast with these, I can make one mistake with the sign, and that just jumbles the whole caboodle. Don't do that. Opposite of times is divide, so we divide both sides by 8, and x equals 16 over 8 is 2. Boom! This method always works. It can yield some large numbers like in the first problem. I want to show you guys one other method. So the other method that you can use, and this sometimes works really well, and sometimes you can't really use it. It's when we're going to start by dividing to help isolate the variable. And now this only works really, or it works well really, if there's a common factor. Okay, works well if there is a common factor. So I will show you this. We have one of our problems was it was 5 times 6x minus 6 equals negative 270. What I have to do, I have to look at, for this to work, I have to divide by this guy. But I have to see, does it actually fit well? Like, does it fit evenly into 270? Well, I know, hey, Anything that has a 0 at the end is divisible by 5. I know that. If you're not sure, you can just go, hey, what's this number divided by 5? Put it in your calculator, and if you get a whole number or an integer, you're going to be fine. So what I do, I can divide both sides by 5 and watch what happens. This guy cancels. Boom. So we don't distribute. Instead of distributing, we divide by both sides by what we would distribute. So now we just have 6x minus 6 equals, and this guy's going to be negative 54. From here, it's classic two-step problem. So plus 6 both sides. I have 6x equals negative 48. And from here, we're going to divide both sides by 6. And I got x equals negative 8. Boom. Now you might say, Mr. Michelson, we got the same answer over here. Yeah, we did. The difference is we solved the problem a different way. We also had smaller numbers. So if you look at these numbers, they are in fact a little smaller than these ones over here. This one over here, when you distribute, you're working with 30x and 30, and you have to play with the 270. This guy over here, once you divide by 5, you get the numbers smaller. So it's easier, in my opinion, to do mental math if you have this situation where you can divide these two numbers and you get an integer, which is a whole number. You don't really want to do this with a decimal. That'd be a little tricky. I will show you guys one more example if you would like to see that method one more time. I'll actually use the same problem we did on the second one, and you can see how different it looks. So 4 times 2x plus 5 equals 36. Instead of distributing, we are going to divide both sides by 4. We know 36 divided by 4 is 9. So now I just have 2x plus 5 equals 9. And you can see the problem is significantly easier on this one. I can just go up minus 5 both sides. And I have 2x equals positive 4. Divide both sides by 2. And I have x equals 2. Boom. There we go. So again, the advantage of this is it can be a shortcut. It gets your numbers smaller, but it only works well, in my opinion, if you have an integer, like a whole number here. So you got to make sure that when you divide both sides by whatever that number that would be distributed, this thing should be an integer, not a decimal. Hopefully that helps. Again, if you have any questions or comments, you can leave them in the comments below. Thanks so much for watching.